A 20-foot ladder is leaning against the wall and the base is moving away from the wall at a rate of 6 feet per second. How fast is the top of the ladder sliding down the wall when the base is 12 feet from the wall? The first thing we're going to do is draw a diagram. So our y-axis is going to be the wall, and this slope here is our ladder. The floor will be our x-axis, and the ladder is 20 feet. So since we have a right triangle, we are going to use the Pythagorean theorem. So that would be x squared plus y squared equal to z squared. And we simply plug in our numbers. So our ladder is our z, so that would be 20 over 2, 20 to the second power. Next thing we're going to do is we take the derivative of our formula. So we use the chain rule, which would give us 2x times d to the x over dt over dt plus 2y dy over dt. And since our ladder stays at 20 feet, we're going to set the derivative equal to 0 because 20 feet is our constant. Next, we plug in all our numbers into the Pythagorean theorem. So since our base is 12 feet, our x is going to equal 12 squared plus y squared. Our y is the unknown for now, equal to 20 squared. So we simplify, we get 144 plus y squared equal to 400. And we isolate 144 and that cancels out. And we put it under 400. So now y squared is equal to 256, and to cancel out the squared, we take the radical, which will give us y is equal to 16. So now we work with the chain rule formula, the formula that we received after doing the chain rule, and we simply plug in our numbers. So 2 times 12 times 6 plus 2 times 16 times dy over dt. Once again, set that equal to 0. this gives us 144 plus 32 times dy over dt equal to 0. And we isolate. In this step, we try to isolate dy dt. So subtract 144 both sides. So this cancels. And then we rewrite the equation. 32 times dy dt equal to negative 144. And we divide by 32. On both sides. And the answer to our dy over dt is equal to negative 144 over 32. We can simplify that into negative 9 over 2. The distance between two ships is 100 kilometers. At noon, ship A is sailing south at a rate of 35 kilometers per hour and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? So once again, the first thing we do is we draw a diagram. So this will be ship A, and it's sailing at a rate of 35 kilometers per hour. I'll just leave 35. The distance between them is 100 kilometers. And ship B is sailing north at 25 kilometers per hour. And our z is the distance between them. So our next step is to simply clean up our diagram. So this is our x and this is y. So what we do is we draw another one, y, z, and this is our 100 because that is the distance that the ships are far apart. And our x is here, but we'll simply move that over to the side of y. So they're basically being combined. So once again, we have a right triangle, and we already know what formula we're going to use. So we plug in our numbers. Our x is 100, so 100 squared plus x plus y squared. We get x plus y because remember that we shifted our x over to be together with our y, equals to z squared, which is our unknown. Our next step is take the chain rule, use the chain rule, which gives us 2 times x plus y times dx over dt plus dy over dt. equal to 2z. 2z times zz over dt. So we want to isolate our z. So we simply divide by 2. And they cancel. Our 2's cancel. So far we know that our dx over dt is equal to 35 for ship A, and for ship B, it's dy over dt is set equal to 25. In order to find our x and y, we simply multiply our dx and dy by 4, since we start at noon and the problem asked us at 4 p.m. So 4 hours is what we multiply by. So 35 times 4 is equal to 140, and 25 times 4 is equal to 100. So these are our x, this is our x, and this is our y. So we simply plug it in into our new formula. So that gives us 140 plus 100 times 35 plus 25 over 100 squared. We're using our original Pythagorean theorem now. Plus 140 plus 100 square. And we take the radical. We're taking the radical because we want to find out z, not z squared. So now we simply solve. So we get 240 times 60 over 10,000 plus 57,600. Gives us 14,400 over 67,600 . That gives us 14,400 over 260, which is equal to 5.538. So that is the distance between the ships at 4 p.m.